So welcome everyone. We're going to be talking about accessing your enterprise geodatabase using SQL today. My name is Melissa Jarman. I'm going to be presenting with my colleagues Parirokh and Amit Kesarwani. So since this session's about accessing your enterprise geodatabase, we're going to have a couple of assumptions of prerequisite knowledge that you have. Assumptions that you have knowledge of relational databases, SQL, and geodatabase concepts. We're all going to be available after the session for questions, so we're going to try to hold those till the end. So I'm going to outline the talk for today. We're going to start out with the basics of database and geodatabase support in ArcGIS. Take a look at the geodatabase system tables and go into how we can access these and query information. We're going to discuss some of the native spatial types and their advantages. Saeed's going to demo how spatial SQL functions perform to do queries and analytics against the data. And then we're also going to talk about the process of editing this data in your geodatabase via SQL. We're going to go into some of the discovery functions that we have. And then we're also going to talk about accessing these data through editing if the data is non-versioned, also if it's versioned. And at the very end, we're going to go through some guidelines just to summarize some points. So there are multiple implementation patterns of the ArcGIS platform. So everything from a database-centric implementation all the way up to ArcGIS Enterprise using portal and server. Most configurations are going to use data stored in some type of geodatabase. So that's a common foundation we'll see. We're going to talk more about the acceptable methods to access these geodatabases using SQL. So from our ArcGIS clients, ArcMap, Catalog, and Pro, you can connect directly to a supported database and view data by making a database connection. We have two different access paths. So we have general geodatabase support. We provide that on 5 databases currently. That's DB2, Informix, Oracle, PostgreSQL, and SQL Server. We're going to be adding geodatabase support for SAP HANA this year as well. You can also get direct, simple feature access to databases that are considered non-geodatabases. This just means that they're not enabled with the system geodatabase tables themselves. These are going to be considered read-only through your ArcGIS applications through the client, and you can publish these to server through a feature service and edit these. So a little bit about the geodatabase. So this is built on additional functionality built on the database itself. So application logic is separate from the database. You're going to enable your database as a geodatabase when you want to do more with your data. So some examples of that would be if you want to go through and control your data integrity for employing subtypes and domains against the feature classes. You would go through and you would have that functionality with a geodatabase. Also advanced modeling, data modeling. So if you want to do a transportation network or you want to use a utility network, that's going to be available in a geodatabase. You can store and work with detailed cartography, so you can use geodatabase representations. Also, you want to use multiple user editing. So this will be our versioned editing. This is going to allow editors to go through and access and edit their data in complete isolation from one another. So when you enable your data, your database as a geodatabase, you're going to get 2 different types of tables. There's user-defined tables. This could be our tables feature classes in the geodatabase itself. And then we're also going to have the system metadata tables. And these tables are stored and controlled by ArcGIS. So there are 4 main geodatabase system tables. These are going to store all the geodatabase behavior. So feature classes that are registered with the geodatabase, relationship classes, subtypes, domains, even down to rules for a topology would be included in here. And it's going to be essentially tracking all the contents of the geodatabase objects that are registered. the geodatabase schema is primarily going to be included within a single XML field. We're going to go into this as well. And one thing I want to note about the system tables, they're okay to query, but never attempt to edit the system tables. So here are the 4 main tables we're going to go through. We've got GDB items, GDB item types, GDB item relationships, and relationship types. You can also see the corresponding relationships that exist between these tables. So the GDB items table is going to be the main table. A record for every item in your geodatabase is going to be listed here. So feature classes, domains, subtypes, even feature data sets are going to be listed here. This table has a XML field. It's going to contain a significant amount of information about the complete description of that item. So for SQL Server, Postgres, and DB2, this is going to be a native XML data type. And for Oracle and Informix, it's going to be an ArcSDE XML that's used for storage. So this table is related to the GDB item types table. This is a fixed list of all items in the geodatabase. So when your geodatabase is enabled, it's going to be a fixed populated list of all items that can be represented in a geodatabase. So that's same domains, feature class, everything down to rules and a topology. Anything you can model is going to be listed in this table. So we know that items in our geodatabase have relationships. So the GDB item relationships table is going to be the pieces that participate in relationships. So this could be a feature class being contained within a feature data set. It could be a domain being assigned to a feature class. So these are going to be the origin and destination pairs of these items are going to be listed in the relationships table. And then the item relationship types is going to be a fixed list like the item types. It's going to contain all the different types of relationships that a geodatabase can have. So what can we do using SQL in our geodatabase? So we can query the system schema and gather properties of existing data sets. Querying's okay. We'll go through this in the first demo. We also can do editing, so we can edit tables and feature classes through SQL level. If it's versioned, we're going to be editing against the version view, and we're also going to demo that as well. We can create tables through SQL, but if you do so, these tables are going to have to be registered with the geodatabase in a separate process. We're also going to go through, Saeed's going to go through and do some SQL functions and leverage the power of the database to perform analysis on attributes and spatial relationships with our data. So just to go over some rules for accessing the geodatabase at the database level. So we want to go back and talk about how the geodatabase is built on top of the database functionality. So accessing via SQL is going to bypass all this logic of the geodatabase that the ArcGIS clients usually enforce. So the database is not aware of this. So it's going to let you do anything as a user you have permissions to do. So it's very important that we're aware of what we can and cannot do against our data. So you need to know your data. You need to know if it's involved in geodatabase functionality, if it's part of a controller data set like a topology or a parcel fabric, if it's involved in versioning, if it's registered as versioned. There's different access paths for this. Just to back up this, you also have discovery functions that you can use if you're unsure and you don't have access to the client. Amit's going to go through some of those and how they can be utilized to query to check if items are simple, if they're versioned, and others as well. So the first thing we're going to do is we're going to go through a demo on querying the geodatabase schema. So we're going to look at the system tables. Querying these is completely okay to do. So we're going to pull information about our geodatabase objects out and gather some information about the relationships they have. So we're going to look at feature classes that are contained within a feature data set. We're going to list the domains and their coded value code and value or description pairs. And then we're also going to find the data sets in our geodatabase that are using a domain. So I'm going to switch over. This particular geodatabase is stored in SQL Server. Can everyone see that text okay? Okay. So the particular database we're going to look at that is a geodatabase is our LA source data. So we're going to go in and take a look at the tables. So just like we were talking about before, geodatabases are going to have a mix of user-defined tables and geodatabase system tables. So we can see the GIS user owns quite a few tables in this geodatabase. The main 4 tables we're going to be taking a look at are the item relationships through the item types tables listed here. So let's just take a look at the GDB items table. So we can see this is an entire list of this geodatabase. So this isn't a very big database as far as what's contained within it. We've got the UUID, the type column. These are GUID data types. And then we also have the name of the object itself. And if we scroll over, we can see the XML definition field that we were talking about, which contains a lot of information about each item. So I'm going to refine this a bit and just give us the name and the definition field. So we can see we have neighborhoods, parcels, incident category, but what type of item are these named data sets? To get that, we're going to join with the GDB item types table to get the data set type name. So this is going to give us this added type column, which I sorted by type. So we can see we have some coded value domains in our geodatabase. We also have some feature classes, and then we have a feature data set as well. So before we go into querying specific items in here, I just wanted to open up the incidents definition. So we know this is a feature class. So within SQL Server, it's going to give us a nice parsed XML view of the data. So this is going to contain a lot of information about this item. We see the fully qualified name here of the incidents feature class. We can also see if it's versioned, items like that. We can also see if it has an object ID field. And then it's also going to show us all the field information. So we can see our object ID field here, and then additional fields in this feature class. So we see category, and then we can see the incident category domain is assigned to this feature class. So there's a lot of information you can gather from just opening up the XML in raw form, but we're going to go through querying some information specifically targeted at data sets we have. So we see we have a lot of items within our geodatabase, but we also have a feature data set. And we know feature data sets are considered containers. Objects are going to be stored within those. So if we want to do a query for what feature classes are contained within the feature data set, we're actually going to go through for the crime incidents feature data set, and we're going to set the container as that, the container type as feature data set, and we're going to join the GDB item types and items table back to the item relationships. And this is going to give us an origin and a destination relationship within there. So we're going to grab the destination IDs of the objects that also have the UUID for that feature data set, and we're going to join that back to the GDB items table to get the name of the feature classes within that feature data set. So we can see here we've got the incidents feature class and the burglary GTA incident risk feature class. So you could easily go through and list out all the feature data sets in your geodatabase and then get a report or a list of items that are contained within them. So next we're going to go through and we're going to look at these coded value domains. So we have 2 in this geodatabase. And if you're familiar with coded value domains, you know that they're going to have a code and a description or value pair. So that's typically a numeric or an abbreviated text character for the code, and then you're going to have a description that's more meaningful. You're typically going to see the the description within your ArcGIS client applications, but when you're going through and doing SQL and you're inserting values into a table, you're going to be inserting the code. So we're going to go through and resolve the coded value domains within this geodatabase. So this is going to give us all of the coded value domains, their code, and their description pairs. This is going to take the GDB items and the item types where the name is coded value domain. And you can see our XPath query here. It's going to search the items table and the definition field. There we go. So we can see a list here of the 2 coded value domains we have. So we have gang-related coded value domain. There's 2 codes and description pairs for this coded value domain. And then we have about 30 different code and description pairs for the incident category. So if you're going through and doing some SQL inserts, you could resolve what field a specific coded value domain is assigned to, and you could use this list to resolve the values that you're going to use for your inserts. So lastly, what we're going to go through is we're going to take a look at the actual classes or tables that could exist in a geodatabase that are using a coded value domain. This is particularly helpful if you've ever come into a situation where you want to actually go in and delete a domain within the geodatabase itself, and it tells you that it's currently in use. So we're going to query what data sets are using this domain. So initially, we're going to use the gang-related domain, and we're going to find the domain and data set relationships by querying the item relationships and the item relationship types tables. So we can see the gang-related coded value domain is assigned to the police report feature class. So if we needed to go in and remove that from the association from being used in that class, we'd be able to use this report to help us do that. We're going to go look at our other domain. So the incident category domain, and we can see it's actually being utilized by 2 different feature classes. It's being used by the incidents feature class and also the police report. So the police report feature class is going to have both of these domains assigned to some of the fields. You can also extend this to actually give you the exact field that the coded value domain is assigned to on this particular feature class as well. So this was just 3 examples of how you could take SQL queries and XPath queries and grab information from the geodatabase system tables. I'm going to pass it over to Saeed, and he's going to go through some analytics querying the data through SQL.
Hey folks, can you guys hear me in the back there? Good, great, thank you. And am I up on the screen? All right. So just a show of hands, how many of you are actually accessing your geodatabase using SQL? Like select star queries, just select star queries out there. Okay, what about spatial functions like ST functions? Mm-hmm. And how many of you are actually doing DML and editing your data? Okay, good, pretty in touch. Crowd out there, one more question, how many are you building third-party applications on top of the geodatabase? Okay, good, quite a few. So why should you actually use SQL on your geodatabase when you have a client application like ArcGIS? And the question really comes down to a couple of answers here. One is you can use the power of your database. We often have these host machines which have lots of resources on them, and we can leverage the power of those resources by pushing down geo processes to our database using SQL. We can use the native spatial types inside of our database. Every DBMS flavor has their own native spatial types, and we can use the power of those spatial types to access our spatial data and do many things with them. We can bridge the gap between GIS users and non-GIS users. often the folks who are making decisions don't have client applications like ArcGIS Desktop and Pro. Instead, they have something like a web browser, so we can publish our spatial data using services and allow these decision makers to access spatial data in that manner. And sometimes you don't really want a full map to make a decision. You just need a single result. You know, how many customers are within some range of a store? Questions like these. So what is a spatial type? The textbook definition is it's an object which stores the location, shape, and properties of spatial data. With a spatial type, you get things that come along with it, like a spatial index, which allows you to search it in a fast, efficient manner. And you have a number of properties which you can access through your spatial type. Things like properties which return information about the spatial type. What's the spatial reference of your feature? You have other properties, other functions that return relationships amongst your features. Perhaps you want to know if a feature intersects another feature. You have spatial operations you can perform, create new geometries, a buffer around a point, for example. And you can also transform one geometry into another geometry, change the spatial reference of it. So what are the benefits of a spatial type? How many of you have used SDE binary before? Yeah, so SDE binary was a type that was stored as a blob, and you didn't have access to it in SQL, meaning you couldn't see anything about it. You couldn't crack it open and see the well-known text representation. Instead, you could only interact with it through the ArcGIS client application. So now with these native spatial types and our ST geometry type, you can actually use SQL to interact with it at the database level. You can create tables with a spatial attribute that are outside of the Geodatabase. You can instantiate new geometries using SQL. You could read and analyze spatial data. Everything exists at the database, and there are no outside dependencies there. That's what's beautiful about spatial types. And you can also write applications to use those native spatial types. The good thing is amongst all the database platforms, spatial types are OGC compliant, so they have similar APIs in SQL that you can use to access these. There are different flavors. For example, with SQL Server, the syntax might be a little bit different than Postgres or Oracle, but they are all basically the same, and you can expect that those functions perform the same exact operations at the database. So how do you use it in our client using SQL? Well, we have two ways that expose SQL. One is query layers, where you can write a query and use query layers to access whatever that query is inside of the client. There are some caveats there. You have to define exactly one spatial attribute. You have to have an object ID field. These sorts of restrictions exist. The other way, which was exposed in 10.5, is you can now register a view with the Geodatabase. So you can create a view in your Management Studio and then register that with the Geodatabase so that we store metadata about that view. And what's great is when you do something like this is you can create complex SQL that answers certain business questions and models geoprocesses and push them down into the database. So for example, in my demo, I'll be showing you this. We have some big, ugly, complex query, and it models a geoprocessing model, but it all exists at SQL. None of this is client-side. All right, so let's go into that. So let me introduce you to the data first, so that this all makes sense. We have two feature classes which we really care about. One is this neighborhoods feature class of the LA County neighborhoods, and the other one that's populating now is incidents. So this is actual data from LA County, and these are crime incidents from 2013 through 2016. It's about a 500K feature class. And The reason we chose this type of data is because it's something which is constantly changing. As reported incidents come in, the underlying data changes. So that's where something like query layers or a view is important, because it changes your answer in real time as the data changes. So what we've done is we wanted to answer a question of how can we expose patterns of crimes, like crimes, in the same area over time? And I was able to do that by pushing a geoprocessing model down into the database to answer this question. And we'll come back to this, but this is the end result. So now let's jump over into SQL Server Management Studio. And let's begin building this query so that we can understand how to answer that question. So the first thing I did was I said, which incidents are within the LA County neighborhood's boundary? So this is where I use a spatial function st_intersects, and this is on the on clause of a join with the neighborhoods. And I did some further filtering on category. I was only interested in burglaries and grand theft autos. So we come back with 1,134 rows. So from there, and I put this all inside of a common table expression, a with clause, which will then be wrapped inside of a view that I end up registering with the Geodatabase. So the next question to answer is this bit here. This is the same CTE that we had earlier from the previous query. And so now we'll get into this bit. So what I did here is I was able to chain spatial functions together in order to, one, create a new geometry, a buffer around my incident, and then intersect it with all other incidents in the same class. So this way I can see, okay, where in my buffer are there other incidents of the same category, burglaries and grand theft autos? This way I can come up with some sort of predictive analysis of zones which are at higher risk. And so the point here is you can chain spatial functions, right? And I was also able to aggregate on object ID on every feature and get information that I care about, right? I got the count of incidents which are in that buffer, and then I also got the average date difference between incidents within that buffer. So this takes a couple seconds, but spatial functions can be expensive. So this point to bring home right here is your queries, your query layers and your views will only be as fast as the query that you write yourself. So you have to be very cognizant of the execution plan and the spatial index which is used. There's often a lot of tuning that goes on behind the scenes here that you'll have to do if you're using SQL yourself. So this is a non-spatial result. We have the object ID, which is unique, neighbor count, and average date difference for each feature. And then putting it all together, we have our view here. And then this is the entire common table expression. And what I've done finally at the end is I've just joined back on to the instance class itself so I can pull out the actual shape. And this is the final result. So coming back to Pro, we can see this is my view, which is now registered with the Geodatabase. I've added a symbology to it based on the neighbor count to normalize with the average date difference. And we can see here that now we can help managers make decisions to say, hey, this is a predictive analysis of where incidents are more likely to happen than they had happened before. And coming back to the slide here, you can see that this is the geoprocessing model, and it is pushed down in SQL via view, which it can be shared out in services or to managers in any other way through the client or a map. So that's about it. I'll hand it off to Amit now, who will do some editing via SQL for you.
Can you guys hear me fine? Okay. So that was a neat demo, the whole model in a SQL. was pretty slick. Thanks, Saeed. So, how many of you have tried to edit some data in SQL and then later on faced problems when you're trying to edit that again in an ArcGIS client? All right, so we have quite a few people here. It's awesome, you came to the right place. So querying is fine, doing the analysis is fine, but editing, you're in the fast lane. So if you're falling asleep, just wake up right now. This is your moment. And we have this presentation on is the presentation up? Okay. So we have these presentations on video.esri.com. Don't try to take pictures. You can just go to that site and you can watch the whole presentation again. And so it's time to kind of focus here on what I'm trying to tell you. So you can create tables in SQL, and table with a shape column is a feature class. Now, if you want to use this feature class with a geodatabase, or you want to use it as a geodatabase feature class, as Melissa mentioned before, you have to register it with the geodatabase. Then you can version that feature class, or you can have it participate in some kind of geodatabase functionality. But without registering, you cannot do that. When you register the feature class, yeah. So when you, are we not in the slideshow? Yeah, we are, right? Okay. Yeah. Okay. So when you register the feature class with the geodatabase, if there is no object ID column, or if there is no column that has a not null integer column type, then the register process will add that column for you. If there already is a column, then it will just use that column and treat it as the object ID column for you. Now, when you're editing these feature classes with SQL, what all can you edit? You can edit feature classes that are simple feature classes, and features that are simple. So point, lines, and polygon feature classes, and any feature class that is not participating in advanced geodatabase behavior. So it's not part of topology or network data sets or relationship types, or relationships. And how you can determine this information at SQL level, we provide a lot of discovery functions. So one of those discovery functions is simple. If isSimple is returned true, then you can go ahead and edit that feature class. If it returns false, please don't edit that feature class at SQL level. You can do all your edits using an ArcGIS client, but don't edit that feature class at SQL level. So if your feature class is a non-version feature class, or if your table is a non-version table, you can edit that table directly. But if you have that feature class registered as version, so you can edit a version feature class at SQL level. It is a simple feature class as long as it's not participating in a advanced geodatabase functionality like topology or network data sets. You edit those version tables or version feature class using a version view. Now we'll talk a little bit more about these version views, but let's look at the object ID field first. So object ID field, as I mentioned, when you register a feature class with Geodatabase, every feature class will have an object ID field. The value for this object ID field is maintained and is generated and maintained by the ArcGIS client itself. And when you're doing non-version inserts at the SQL level, we provide you with some database functions that can be used to generate these object IDs the way it happens in an ArcGIS client. So you can use these functions to determine what is the name of that object ID field. So if it does not have a default name like the object ID, then you can use this function to determine what the name of the object ID field is. And then you can use the next row ID function to get the next row ID that you can use for inserts. When you are doing inserts in a version feature class, since you're doing it using the version view will take care of generating those object IDs, and you don't need to insert any object ID in the object ID field. Now you never want to update these object ID fields. Once it's generated and inserted, then that's it. When you do any deletes or any edits, you can do it on the attribute, but don't edit the object ID field. So when it comes to editing the version tables or feature classes, as I mentioned earlier, we are going to talk about version views. So when you register a feature class or a table with the Geodatabase as version, a version view gets generated. A version view gets automatically generated, and you cannot see it from Arc Catalog because we want to hide it. It's not useful from Arc Catalog itself. It's exclusively generated for you, or for you to do edits at SQL level. So at SQL level also, you get the same versioning experience. If you have multiple editors, you can use all these generate versions and assign these versions to specific editors, and they can all edit the data at the same time as long as they're editing in their own version, and they won't log the table or for other users to use it. So when you register these feature classes, there are some ancillary tables that get that are made in the database, adds and deletes table. And when you do any edits or adds or inserts in these feature classes, these edits go in this adds and deletes table, not in the base table. That's why we ask you that you do your edits using these version views. So all these edits, they get assigned a state ID, and these state IDs, they correspond to each version that you're trying to edit at that time. And the lineage of these state IDs is how we track all these versions. So I mentioned about the version views. So basically, these version views are not just simple views. They are a collection of views that are using store procedures and triggers. As you edit or insert in these views, they do edits in some other ancillary tables. Now you can do all the edits at SQL level, but when you do the reconcile and post, you have to do that using an ArcGIS client. Now here is a list of discovery functions. We won't go over each and every one of them, but this is just a sample list that's available that you can use for finding the information about the table that you're trying to edit at SQL level. Now let's see a demo how we can do these non-versioned and versioned view edits. Okay. So here, let's look at the map first. I've got two feature classes, reported incidents and police stations. So reported incidents is a non-version feature class. Police stations is a version feature class. Let's try to edit the reported incidents feature class first. So currently, let's see, we don't have any incidents reported. Pretty crime-free community. We live in a great community right now. And let's check if it's a simple. It is a simple feature class. Let's find out what the row ID name is. That way we can use that information to generate the object ID and insert that. So in SQL Server, you cannot use inline functions. So we declared a variable and we'll put that value in that variable and use that variable for inserts. So here, if we do this, you can see as many times as I run, it's going to generate a new value for you. So we'll use some information that Melissa generated for us by inserting a coded value in one of the columns. So category column is using a coded value domain. So in category column, we are actually inserting a number. Okay. So let's do these inserts. I've got this one record and a couple of more incidents. So we've done the inserts here. Now if we go, we can see these inserts are visible. And as I mentioned, we inserted a coded value, but you can see in category, there is no number, it's actually the value that corresponds to that code. Okay. So, and we can check the inserts at SQL level also. Now you can truncate this table at SQL level, make the community great again. But when you do these truncates at SQL level, the sequence does not get reset. So if I do these inserts again, now these are gone, and then we do these inserts again, what will happen is it's going to get next values. So now you see the object ID starts at 9. Now if you want to truncate this or reset the sequence, there is a geoprocessing tool called truncate table. You can use that tool and the sequence will get reset to 0 or the start of the feature class. So now we saw how we use the values that Melissa had found using her queries. Saeed did an analysis using the crime incident reports that were there. We got the report from the LA County. Based on that report, LA County thought that, okay, we'll make some more police stations. So they generated one more version of that, or they generated one version called future or planned stations. Now we want to edit that version of data for police stations. Now let's just do our checks that we usually do. For some reason it's telling me it's false. I don't know what went wrong here, but I know it's a simple feature class. And we'll try to go and get the version view name here. So now we know this is the version view. We'll see how many records are there in the default version. We got 106 police stations. Now we'll change our version and see how many records are there in the planned version. So it's still 106. Now we want to edit this version. So there is a function called edit version, and we supply a parameter called 1 to start the edit session. So we'll start the edit session here, and we'll begin the transaction, And here we are doing an insert and one update. So one of the police stations is going to be changed into a sheriff station. We do the execute. Now here you can see that it was just one insert and one update, but there are many other transactions that have happened because the version view is using these triggers and stored procedures to do the edits into the adds and delete table. Once you're done with your edit, you can stop editing. And let's check the count now in the version. And now we have one record added here. Now if we go back to the default version, you can see that that one still has 106 records. Let's check the same results in the ArcGIS client. Here we're looking at the default version right now, and the Torrance station is still a police station, but in future it will turn into a sheriff station, and here is a new police station that is planned for the future. Okay. So we saw how we can query and analyze the data using SQL, and how we can edit some of the data. Let's summarize all these things that we learned so far. When it comes to editing or querying the database, you're going directly into the database. You know that it's a database, it's a geodatabase, but at the database level or at SQL prompt, there is no way for the commands to know that you're dealing with a geodatabase. You need to remember that you are querying or updating or editing a database. You need to remember the behaviors that you need to enforce or the rules that you need to follow. So database, you're going right at the core of the application here. There's no filter of ArcGIS client that can enforce the behaviors that are required to maintain the integrity of the geodatabase. Now I summarize these things that are allowed and that are not, well, I won't say they're not allowed, but you should not do it. That's why I use those signs. You can query all the system tables, but never edit or insert in the system tables. Simple feature classes you can query, edit, update, or insert into. In the complex feature classes, no editing or inserts should be done. You can query it, but you need to really know the schema of the complex feature classes. So if you're editing any attributes from network data sets or topologies, you really need to know how the schema is for that particular geodatabase functionality and what ancillary tables to join when you're doing those queries. So you can get the answers, but if you don't know what you're doing, the queries are not as simple as querying a non-version feature class or a version view that you're trying to get the information from. So you can perform all the spatial operations. You can do insert, update, and delete on the geometries as long as you're doing it on the simple feature classes. You can insert, update, and delete the attribute data for the simple feature classes. And make sure you write efficient SQLs, because we are not going to parse, or not parse, but we won't rewrite the SQL for you from the ArcGIS client to improve it in any way. Whatever you put in the ArcGIS client for analytics, if those queries are not efficient, then it will slow down your system. Again, do not update the object ID field, ever. Don't modify the geometries where the feature classes are participating in. complex or advanced geodatabase functions. Do not update or edit the attributes of any of these feature classes that are not simple and they're participating in advanced geodatabase behavior. You can use all these discovery functions to find out what is the state of the table that you're trying to edit. All the scripts that we showed you here are also available in the help document. So this link right here, if you're using SQL to access your geodatabase, is your Bible. Go through it and make sure that you're following all the rules. And please fill out the surveys. We do get good feedbacks and we try to incorporate those things in our presentations. So now we'll open the floor for questions. Okay.
So we partner with a vendor that's, rightfully so, a big fan of creating ERDs, entity relationship diagrams prior to beginning work. And I believe too, it was mentioned earlier that, there's a lot that we can basically do with SQL and treat these objects as SQL objects, but things like foreign keys and other types of requirements I would be really hesitant to do. How would you approach creating an ERD for an enterprise geodatabase? Because when I describe it to them, all of these different factors and rule sets inside of the enterprise geodatabase, it doesn't translate. So how do you recommend diagramming when you start out the database or working with other SQL developers and they're not familiar? How would you?
Okay, the question is, how do you use entity relationship diagrams with the geodatabase and what are the best practices there? And we had at one time we supported a tool called Case Tools, which is now essentially deprecated with ArcGIS and has been replaced by a third-party vendor called Sparks. So if you come up later, I can point you in the right direction. But you're right in the fact that we don't support foreign keys and primary keys at the database level. Instead, that should be used with our relationship classes. That relationship between feature classes should be used with the ArcGIS concept of relationship classes.
Is there an efficient way of utilizing the spatial query element of SQL Server using two data sets that are two different productions?
So the question is, can you use the spatial query to use spatial functions at the database level to query two separate spatial tables with different spatial references? And I believe the SQL Server spatial functions don't allow you to do those type of relationship tests if they are differing spatial references. I think you have two concepts. So the question is, first, are the old SDE commands, like layer, still supported or replaced with ArcGIS? And
Only part of the API that dealt with layers is the same one that you did in your demo.
sure. Do you?
So you're talking about the query layers and you want to use that with the SD API. Is that correct?
Yeah, it's essentially great. You want SDE API allows you to create a layer instead of view. Right? What the data is that. So from what I'm understanding, version 10.5, those functions that you want SDE API have been migrated to the function. That's question one. Question two, will ArcGIS server allow application on those in-memory or queries?
Okay, so you are actually talking about the views. It's not an in-memory thing. It's just you're talking about the views. You can what Saeed mentioned was that we allow the views to be registered with the Geodatabase now, and yes, you can publish that data that is based on the view onto ArcGIS server.
As a query only feature service.
Yeah, the only difference is that it's going to be only a query only feature service. It won't be a editable feature service. Okay. Okay, I could not hear the second question properly. Let me answer the first question first. The question is it the same procedure to edit the archive views? Right, correct? Okay, so the discovery functions can be used for identifying what is the view name of the archive views. So once you have the archive view name, you will follow the same kind of workflow for using the archive view. We can talk about your second question afterwards. Any other questions?
That over here. Yeah. Go ahead. Correct. So the question is, how do you set up a PostgreSQL database in order to use the SQL in the database access behind our client? I believe you have to install the spatial type, the STGeometry spatial type, in order to do that.
So for Postgres, I think we do provide a ESRI spatial type for Postgres, and the PostGIS is the native spatial type that can be installed also as into your Postgres database. Yes, you can use either or both. That's correct. Yeah, so the question is there documentation about it? Yes, there is a documentation for setting up the ESRI spatial type. Right? Okay.
When you set the current edit version for editing a conversion view, is that a global setting or is it just for the session it's set?
So the question is, when you set the current version, is that a global setting or is that for that session? It is for that particular session. It is not a global setting. So the default version is always queried by default, and you can do the edits in the default version also. But if you want to edit a particular version that you have created, then you need to execute set current version for it. Okay.
Will the slides be available later?
Yeah, you can take our cards and we can email you the PDFs. And as I mentioned, the videos are going to be available online, so the slides are included in the video. Okay.
When your data's in an older version and you have to run like the migrate tool to get geometry type from ESRI binary to SQL geometry type, what does that actually do to the tables? Is there anything that when you do that the users are going to notice on the other end? Does that make sense?
So the question is, when you migrate the shape type or the geometry type, do the end users feel any difference? So from application point of view, there won't be, or from the end user's perspective, they won't notice any difference because the geometries have gone from blob or binary to a spatial type of geometry.
The shape field gets a different name now? Does it change from shape, there's like a shape dot length and a shape dot area field that get changed?
No, those fields, they don't get changed. The name of the shape field changes.
Those are dynamic fields.
Yeah, but not the shape field, right?
But the type changes from an integer to the spatial type. And then the dynamic fields that you see on a business table for area and length, those will change to reflect the name of the function. So instead of shape.area, for SQL Server, it would be shape.st area.
So anybody that's querying those layers somewhere else referring to a shape dot length or shape dot area will
Those would be different, but it also would depend on how you are doing that query. So if you're calling an object function to retrieve the area or length, that should automatically adjust for you. But if you were explicitly looking for the attribute field by name, then yeah, that would probably change.
So we'll go ahead and close the session for now, but we'll keep on taking the questions right after we get off the stage. So you can come and talk to us either off the stage or in the island. Okay. Thank you.